Today we're going to talk about rational and irrational numbers. A rational number is a number that can be written as a fraction. Now really, what does it look like? It's a repeating or terminating decimal. 2 is terminating. It ends. We know what the next number is. 2/3 can be written as a fraction, so all fractions. -1/4 still just a fraction. 3 to the 8th. That means what number times itself 3 times gives us 8? Well, it's 2, and 2, we already said, is rational. -5 can be written as a fraction, -5/1. Square root of 9 is 3, so it's a whole number. We can deal with that. 5.1 repeated, that's a repeating decimal. Or 0.333 repeated, repeating decimal. All of those are examples of rational numbers. Irrational numbers are the opposite. A number that can't be written as a fraction, or non-repeating or non-terminating decimal. Pi is the most famous irrational. We have 0.3475 ... It doesn't repeat, it just keeps going. And then square roots of non-perfect squares. We can't take the square root of 7 and get a whole number. So this is the key. These are the different ones. So if you see a square root of a number you can't take the square root of, it is irrational. So if we go through here and classify, letter A is rational because it's a terminating decimal. It ends after the 3. B is irrational because it's not a perfect square. We can't take the square root of 5. C is rational because it's a pattern. 347, 347, 347, ... We know what the next number is going to be. It's rational. It's a repeating decimal. Next one is rational because negative square root of 81 is really just -9. And -9 can be written as a fraction, -9/1. Same with letter E. Square root of, or the cubed root of 8 is 2 because 2 times 2 times 2 is 8. So it's actually 2/1, which can be written as a fraction. Letter F is irrational. Even though there's a pattern, 1 1 2 2 1 1 1 1 2 2 2 2 2 1 1, it's not repeating. It's a different kind of pattern. So it's irrational. It's non-repeating and it's non-terminating. It keeps going on forever. Now, trying to graph these on a number line. -0.4 is somewhere in between 0 and -1. For some reason, it got erased on me. 3/2 is 1 1/2, so between 1 and 2. 0, pretty easy. Square root of 10. Well, we know that's not a perfect square, but we know that square root of 9 is 3. Square root of 10 has to be a little bit bigger than 3, but not quite as big as 4, because that would be the square root of 16. -1, plot on -1. -3.5389 is about halfway between -3 and -4. So we write them in ascending order, lowest first. -3.5389, -1, 0. Oh, I forgot my -0.4, 0, 3/2, square root of 9, square root of 10. Letter B, same thing, square root of 5. Well, it's a little bit bigger than square root of 4, which is 2, so it's in between here somewhere. 0.3 repeated is 1/3 really is a fraction, so it's 1/3 of the way from 0 to 1. -5/3. Well, 3 goes into 5 not quite 2 times. It goes in 1, so it's between -1 and -2. So I put it right here. 1 1/2, halfway between 1 and 2. -√4 is really -2, so we just plot that on -2. And cubed root of 64, what times itself 3 times gives us 64? 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So the cubed root of 64 is really 4, so we can write it there. So here's our ascending order: negative root 4, negative 5 over 3, 0.3 repeated, 1 and 1/2, square root of 5, cubed root of 64.